Best parts about graphing lines is that even though we're going to be learning something new in this section, it's going to continue to use all of the information we've been working with up to this point. This video is going to be covering graphing lines in point slope form, and point slope is something that's a little bit different than what we've been working with before, but it's still graphing the same line. You can still graph them using a table, you can graph them using slope intercept form, or you can graph them using any other method we've learned up to this point. So before we learn about point slope form, I want to just quickly review the other forms that we've been working with before. Now, the first one is y equals mx plus b, and I'm hoping the song popped into your head, at least for some of you, and we call that slope intercept form. And we call it slope intercept form because mathematicians are not very creative with their naming processes. This thing uses the slope, which we call m, and it uses the y-intercept, which we call b. So we call it the slope-intercept form because it's using the slope and it's using the y-intercept. A couple examples of stuff that could be written in slope-intercept form could be y equals 2x plus 3, or something like y equals 1/2 x plus 4. When we're working with standard form has all of the x's and all of the y's on the same side, but no fractions involved. So for example, 2x plus 2y equals 4 could be an example of something written in standard form. As we look at point slope form, it's written in this form. Now, this looks really crazy, but I outlined the red here to indicate that these are the things you replace with regular numbers. So y1 comma y2 in red, or sorry, this should be x comma, sorry, I messed that up. This will be x1 comma y1 is just an ordered pair. So these numbers here, so for example, if this ordered pair is 3 comma 4, we are going to be replacing the x here and the y here. And we do that because point slope form needs a point and the slope in order for the line to be filled out. Here is the slope, and then here will be our point. Now, I know that looks a little strange right away, so I wrote it down in this other form here, that we have y minus something equals m parentheses x minus something. And we are going to be filling in these boxes with the point, or the ordered pair, and the m with the slope. So before we start graphing, I want to just find the slope and the ordered pair when we're working in point slope form. So let's look at the line on the left here. We have y minus 6 equals 4 parentheses x plus 5. And as a reminder, point slope form is written like this. One of the things we have to be very careful of is this sign right here is already a negative. So, for example, in this one, the y value will be positive 6, and the x value will be negative 5, because that's a negative sign right here. That's a positive. So the ordered pair is negative 5 from here and positive 6 from here. The m value is still our slope, so the ordered pair is still just 4. If I'm writing this in reverse, let's say I have this blocked out. I'll even put a box up here to block it out. Whoops, that's not what I wanted to do. Put a box here to block it out. Okay? So it's asking us to write this information in point slope form. Well, we know that point slope form is y minus an ordered pair, parentheses x minus the x part of the ordered pair. So I'm going to do y minus, and I go here, and so it's going to be y minus 6 equals m, which is our slope, which in this case is 4, parentheses, x minus our x value? Well, x minus -5 is the same thing as x plus 5, which we had up here at the top. Okay, so you can do x plus 5 or x minus a -5. So the problem on the left, our ordered pair, we look at the y value right here. So this is +1. We wanted y minus something. That makes our y value -1. And our x value is -2. Well, it's already subtracting, so that makes this +2 right there. Our slope is always the coefficient outside of the parentheses, so it is -7, or we can write -7/1. So let's actually work with this out in an actual line here for a second. So write this line in point slope form. So for this line, in order for point slope form, I need one point and I need the slope. Well, we have a ton of points here, and we can use any of them to write this in point slope form. Before we actually do that, though, I want to find the slope between any of these points. So I'm going to pick these two right here. So this point and this point to find the slope. My slope is going to be rise over run. So I'm going to rise -1, -2, -3. And then I'm going to run +1. So that makes it -3/1, which makes my slope -3. Now I can pick any of these ordered pairs. So I'm just going to pick 1, 2 right away and use that. Point slope form from before is y minus y1, which is just a number, parentheses x minus x1, which is just a number. I can remind myself that by noticing that the notation puts a little 1 here, which tells me the x has to be a number. So we do y minus, our y value here is +2, equals, our slope we said was -3, parentheses, x minus our number of +1. Now, what is interesting about point slope form? Some of you might already be asking the problem, or asking the question of, why are we learning point slope form if we can already graph in slope intercept form, or we can already graph in standard form? Why do we need this new thing? And what's really nice about point slope form is we just graphed with this ordered pair right there. But we can actually graph point slope form from any ordered pair. For example, if I wanted to graph in green here, I would do y minus, our y value is 11. Our slope is still a positive or -3. So I would do x, in this case, this is a -2. So I do x plus 2. And I can graph that line. I could also graph, this line here in blue by doing y minus 8 equals still -3, parentheses, x plus 1. So the nice thing about point slope form is I have this equation, I have this equation, I have this equation. Those are all the same line. And just because our standard form equation up here was 6x plus 2y equals 10, that's the only standard form equation you can write for that line. But you can write an infinite number of point slope equations. So it gives us a little bit more flexibility when we're working with lines, especially ones that don't intersect at a nice clean number like 5. As always, if you have any questions, please let me know. This section is tough, so it's not a bad idea to plan to watch the retake video regardless of how you did on the original.